Hey, I'm Eric. Here I have a ball. Now I'll give it a spin and a push. Now look at its curving trajectory in the air. This phenomenon is called the Magnus effect.
The Magnus effect, named after German physicist Heinrich Gustav Magnus, who demonstrated it in 1852, is what causes a spinning ball to curve in the air. As the ball spins anti-clockwise, it drags air with it. On the right, its spin opposes airflow, creating higher pressure. On the left, spin and airflow combine, leading to lower pressure. This pressure difference pushes the ball to the left. One of the real-life applications of this phenomenon is the Flettner rotors, which are rotating cylindrical sails that use the Magnus effect to convert sideways wind into forward thrust, boosting fuel efficiency on ships. Looking ahead, future nanobots could use the Magnus effect to steer in our bloodstreams. Their spin would convert the blood's flow into directional movement, allowing precise navigation for medical tasks. And that's the Magnus effect, showing the power of rotation. Thank you for watching.